Okay, so I'm just going to briefly go over Clathrin vesicle assembly. To start off, Clathrin normally will be shown as something like this. So Clathrin itself, the name Clathrin comes from this here. This three-pronged shape is a Clathrin protein, Clathrin molecule. This is the outside. These little shapes connect together to form an outside sphere for a vesicle. And so where are Clathrin? Where does Clathrin vesicle transport take place? It takes place here. So the yellow section, all of these yellow chains are assisted by Clathrin vesicles. So it's anywhere from the plasma membrane, the outer membrane of the cell, inwards, all the way to the ER. So all of the other kinds of transports happen between the between the plasma membrane and the Golgi apparatus. All the other kinds of transport are from the ER to the Golgi apparatus, but Clathrin is the only one that is outside. So it's from the plasma membrane to the Golgi apparatus. It's the only one that interacts with the lysosome, the endosomes. It's involved in the secretory process because, like I said, anything that's going outside of the cell is using Clathrin. You see all these little yellow things are Clathrin. So what is Clathrin? How does it assemble? So we're going to look at this image first right here. So like I said, this is the shape of Clathrin. This right here is a Clathrin molecule. These are going to bind together to make a vesicle. It's going to give the vesicle its shape. It's semicircular shape. It's going to make a bunch of almost like hexagons. They're all going to combine together and they're going to look semicircular. But it's all going to start with a cargo receptor. So we're going to look at this image down here. It all starts on the surface of the cell, plasma membrane. So that could be any of these over here, any of these that we see a little yellow section. Let's just pretend it's this one. So it's from outside in. We're going to start off with a donor membrane. We're going to start off with a donor membrane. So this is our membrane here. And in that membrane, there are many cargo molecules, cargo attachment points. These are cargo receptor proteins. So these things have a little shape right here that they can take in any little cargo that is the right shape. They just attach right there. When we get attachment, when we see a molecule come into this little cargo receptor, we get an adapter protein called AP2. That name's not very important, but adapter protein will attach. And once you get an attachment of the adapter protein to the cargo receptor, it allows for a slight bending of the membrane. So just this right here, just this conjugation starts a little bit of a bend in the membrane. That encourages more adapter proteins to come in and bind to other cargo receptors. Because these are all along, these right here, are all along the plasma membrane. And these are floating freely in the cytosol. So all it takes is a little encouragement for these to start forming. Once one of these forms, you'll have Clathrin, this green molecule here, that free floats in the cytoplasm, as shown over here. Free floating around, will come in, bind to this site, and cause an even bigger bend. From a little bend to a bigger bend, and that bigger bend causes even more of these to come and form these little subunits here. And then once those form, more Clathrin comes in, and after a little bit, you have a whole Clathrin skeleton surrounding the vesicle. With that Clathrin skeleton, you then start to have a pinching. You start to have a small section right here. So once the vesicle is nearing completion, we're going to start seeing something called dynamin come in. We're going to want to start to pinch this off. The cell wants to cut right here. It wants to remove this last little section, cut this across, and form a full vesicle. But to do that, it needs a little help. It needs help from bar proteins and dynamin proteins. Bar and dynamin proteins bend. They bend this right here inwards. So they're going to pinch this off. And all of this is assisted by ARF. A-R-F. ARF. As long as we're dealing with copy 1 as here. As long as we're dealing with Clathrin or Cope 1, we're using ARF. ARF is the starting and ending of Clathrin and Copy 1. SAR is the one for Copy 2. And there's a different one for Retromer. But ARF comes in after, or as these are pinching off this section. So it's about to detach, it's about to come apart. And ARF finalizes the last adapter protein binding. It comes in and, see, we're still missing one. If this was to cut off and float away, if this just cuts and this floats away, we're still missing one Clathrin. Because of that, we need ARF to come in, finalize that breakage, and add one more adapter protein. After we detach, you then have a free-floating we have a free-floating Clathrin vesicle, and auxilin, a protein, can come in, find this, get in between these, and separate this bind. So it's able to detach all of those bindings between the Clathrin and the adapter proteins using HSP70, which we've seen before. It's a pulling protein, HSP70, a pulling protein. Using that, it separates all of these from the cargo receptors, and these float freely in the cytosol to be reused in the beginning here.